Topic number 5 is symbolic constant. Okay, symbolic constant is a constant value that is declared with an identifier using the constant keyword. A constant's value may not be changed. Okay, for example, constant integer max num is equal to 100, meaning that this max num is variable, and this variable is declared as a constant integer. So with a value of 100 is assigned to max num. Now examine this template. Okay, at the beginning we have preprocessor directives. Okay, meaning that what is the hashtag include, okay, IO stream, okay, that's preprocessor directives. Then integer main, there's a main function, okay, main function header, and then now we put the symbolic constants, okay, before we write other codes for your program. So symbolic constant we declare right after the main function header. For example, this one, okay, preprocessor directive, okay, the main function header, and then symbolic constants, and then the main function returns 0. Okay, so now we have an example for this. So in this example, prime, okay, is declared as a constant double variable, okay, with the value of 0.04. So later on in your code, okay, you can use this prime, okay, to do calculation. You without have to change without have to use 0.04, okay, every time when you want to use this value in your code. Okay, for example, interest, you have 0.04 times the amount, okay, you get the interest. Then probably inflation is equal to prime times some number, you get the inflation number, and so on. Okay, for example, this is how we use a constant value in your programming. Okay, so number 6, okay, common programming errors. Okay, now we have a closer look at common programming errors. Okay, programming errors may be detected in 4 ways. Before a program is compiled, okay, that's checking while it is being compiled, that's compile time errors. While it is being run, runtime errors. While examining the output after completion. Okay, before you compile, before you hit run or compile, you have to check the code, okay, manually, okay, by your eyes. So if you detect any errors, any mistakes you made in your code, okay, that is called desk checking before the program is compiled. While it's being compiled, okay, if you think, okay, if you pass this one, you think your code is free of error, you hit run, okay, and then the code couldn't run, okay, the code couldn't compile. So that means you have a compile time errors, okay, something is wrong with your syntax. Okay, so that's compile error. So what you need to do, you have to look at the debugger, okay, and see the code, the error codes, okay, what error is there in which line. You go back and fix the error there. Then the next one is while it's being run, runtime error. So sometimes the code, okay, is you are able to compile the code, okay, but when you run, you key in the data, it gives you error. Okay, so this is called runtime errors. Still, you need to go to the debugger and see which line is causing the problem. Then you go to that line and fix it. Okay, the last one is while examining the output after completion. So sometimes you run the program, okay, you get results, but then that result, okay, doesn't make sense. Something is wrong with the result. Okay, that's what it means here. So as an engineer, you have to always check the output. Okay, it's not that you get the output, you get the value, and then that's it, and then you just tell people that, oh, this is the value that you get from the calculation. You have to check whether the results make sense or not. Okay, if it doesn't make sense, you have to go back to your code and check for the error. You have to check, you have to double check the equations you use, okay, in your calculation. Okay, make sure they are all right. Okay, otherwise, okay, something must be wrong if the result doesn't make sense. Okay, you have to have the ability to judge whether that result makes sense or not as an engineer. Errors may be syntax errors. Okay, so means typos in the source code. For example, you want to declare constant integer, what is that, Mary. Okay, instead of constant CONST, you type CNST. Okay, that's syntax error, typos error. Okay, or maybe you forgot to put semicolons. That's syntax error as well. So logic errors, okay, is quite difficult to detect and difficult to find the source. Okay, that's why when you develop your program, flowchart is very important. Okay, so I told you before in your first chapter, in the first chapter, okay, that you have to define, you have to make sure the program flow, okay, is correct. You have to design the program flow first before you go and do the coding. Okay. Program tracing, stepping through the program by hand or with a trace tool. Okay. Or debugger program that allows the interruption of a running program to determine values of its variable at any point. Okay. We'll use this, okay, more often when it comes to this practical programming class later on. Okay, so failure to declare or initialize variables before use. So that's very common also in programming. Okay, so remember all variables. Okay, so you have to identify the variables they want to use. Okay, and remember to declare them. Okay, make sure the variables you want to use is declared with the data type that you intend to use. Failure to include the preprocessor statement when using a C++ pre-program library. Okay, for example, you want to use square root function, okay, in your calculation, but you did not include the CMath library. So that is also quite common also. So passing the incorrect number of types of arguments to a function. Okay, for example, the square root function. Okay, square root function, it takes in integer or double. Okay, double type variables, integer type or double type variables. Okay, but instead you give it a string. Okay, data type. Then that is wrong. It won't compute. Apply increment or decrement operator to an expression instead of an individual variable. So this is common also when it comes to looping. So I++ or plus I. Okay, so which one to use? So you have to be very careful, okay, with that. Next one, failure to separate all variables passed to Cin with the extraction symbol. This one is also very common. So you see this symbol, okay, the angle brackets, okay, the direction of angle brackets, which one to use, the left one or the right one? Okay, Cin, Cout, okay, different extraction symbol. Okay, failure to test thoroughly. Okay, you probably, after you've done the programming, you just key in some numbers and then you find that you get results. Okay, but you did not check whether the result is correct or not. So that's failure to test thoroughly. Okay, compiler dependent evaluation when increment or decrement operators are used with variables that appear more than once in the same expression. This one, when it comes to looping, okay, you see this problem. Okay, especially when you want to use counter. Okay, you forget this error occurs often when people forget to reset the counter number. Probably use counter is equal to 0 and then you do the counter for the first loop, okay, then you get the final counter number is 100 maybe. And then you forget to set back the counter to 0, okay, you forget to set counter back to 0, okay, then you do another looping again, okay, so the counter will start from 100 instead from 0, okay, so for the second loop, so you get error here. Okay, so for summary, okay, scene object provides data input from keyboard, program is suspended until the input arrives. Okay, use a prompt to alert the user to provide input expression. Okay, means that before you ask, you have to ask the user. You have to give the you have to prompt the user, okay, what to do, okay, what input to key in. Okay, you cannot just give it a blank, give the user a blank screen and expect the user to know what to key in, right? So this is what it means here. Okay, to increase the user friendliness of your program. So the expressions are evaluated based on the precedence and associativity, okay, the assignment operator, increment operator, decrement operator. Okay, next one is include CMath for math functions. Arguments to a function must be passed in the proper number, type, and order. Okay, so this one is very important also. So for example, you want to use the power function in CMath. Okay, so power function takes in two arguments, right? A and B, okay, means that you get A to the power of B. But instead, okay, you pass in the wrong data type for A and B. Okay, maybe you pass in the, what is that, character or string data type to A. So wrong. Okay, or in another case, okay, you may want to calculate A to the power of B, but instead you pass in the arguments, okay, power B A. That's wrong. Okay, so if you pass in B A, then you get B to the power of A instead of A to the power of B. Functions may be included within larger expressions. Okay, constants are named values that do not change. Okay, constants, okay, we have seen that before. So that's all for this chapter. Thank you very much.